Have you ever wondered how our ancestors could literally read a story written in the dirt? I mean, how a few faint marks in the sand could be the difference between eating and, well, not eating? Today, we're going to unlock the science behind one of humanity's oldest skills. We're diving deep into systematic tracking.
And this quote just nails it. This isn't about some kind of magic or sixth sense. No, it's a super rigorous methodical process. It's a science. So let's jump right in and see how it actually works.
So how do you read between the lines? Well, expert trackers use this very specific framework, and it's called systematic tracking.
Okay, what that really means is that it's a cautious, evidence-first approach. Think of a detective showing up to a crime scene. They don't just guess what happened. No way. They meticulously gather every single clue before they even think about forming a theory. For the tracker, it is all about the data.
Now, this is where it gets really interesting. Systematic tracking has a creative cousin, you could say, called speculative tracking. So systematic is all about what the evidence tells you. You're reconstructing the past piece by piece. But speculative? That's about making a bold prediction, a hypothesis, about where the evidence will be next. For today, though, we're sticking with that systematic foundation.
All right, so if it's all about evidence, how does a tracker actually start collecting it? Well, it all kicks off with a really fundamental two-step observation process.
First things first, a tracker has to know their environment inside and out. They need to know its normal, baseline state, how the leaves are supposed to look, how pebbles sit, how grass is supposed to stand. It's only with that super deep knowledge that they can spot a tiny disturbance, like a single overturned stone or a few bent blades of grass, and recognize it as a meaningful sign. It's a piece of the puzzle.
And I mean every sign. A footprint? Yeah, obviously. But also a broken twig, a scuff mark on the ground. Each one is a data point. It's a fact that tells you a little piece of the story of what went down when nobody was watching.
And get this, a single, good, clear footprint can tell you a staggering amount of information. We're not just talking, oh, a deer was here. A skilled tracker can tell you its direction, its speed, was it walking, trotting, running. They can estimate when it passed by, and can even pick out unique features, like an individual animal with a chipped hoof that makes its track totally unique. It's incredible.
Okay, so collecting all those signs, gathering the data, that's only half the battle. Now what? Well, the next step is to process all that info. And for that, you need a powerful mental tool set, a continuous cycle of logical reasoning. This is what we call the bottom-up part of the process. You start small. You look at specific, individual things you've observed, and you start to see a pattern. You're building up to a general rule.
So, for example, after seeing dozens, maybe hundreds of Gemsbach tracks, a tracker starts to think, hey, wait a minute. Every single one of these has these two pointed hoof marks, and they're all about this size. From that, they create a general rule. Okay, all Gemsbach tracks look like this. They built a mental model right from the evidence.
All right, then comes deduction, which is the top-down part. This is where you take that general rule you just made, and you put it to the test on something new.
So the tracker finds a brand new track, they look at it and they ask, does this fit my rule? It has the pointed marks? Check. It's the right size? Check. Because it matches the general rule they built from all that past experience, they can confidently deduce, bingo, this has to be a Gemsbach.
And there it is, the whole cycle, right there. You observe, you induce a rule, then you use that rule to deduce a conclusion. And this isn't a one-and-done kind of thing. It's a continuous, self-correcting feedback loop that just gets smarter and more accurate with every new track you see.
Now, this whole process, systematic observation, gathering evidence, logical reasoning, does that sound kind of familiar? It should, because this builds into a much, much bigger idea. Maybe one of the biggest ideas there is.
Let that sink in for a second. The method we just walked through, that cycle of observation, induction, and deduction, it is the scientific method. It's the fundamental logic of science itself, born out of pure necessity. I absolutely love this quote because it just flips the whole script. It's not that trackers are trying to think like scientists. It's that scientists, at their core, think like trackers. The ability to connect visible signs, like tracks, to invisible causes, like the animal that made them, well, that's the exact same mental muscle a physicist uses to connect experimental data to the fundamental laws of the universe.
So why does any of this matter? Because understanding tracking as the first science is, well, it's profound.
It shows that our ability to think logically and use evidence isn't some new invention. It's a deeply ingrained survival tool, something our brains have been perfecting for hundreds of thousands of years just to find the next meal. And that leaves us with one last big, provocative thought. If the human brain evolved to master this incredible process of systematic, evidence-based reasoning, if it was literally built to think like a tracker, what are its limits? What else are we capable of?